Alrighty. I skipped examples 9 and 10, and that's okay because I feel like example 9 and example 11 kind of have a similar feel in that there's a function, an f function with another inner function, kind of like number 11. And then number 10, a composition of two not explicit functions, and then same thing with number 12. So I'd rather do 11 and 12 that are going to link us to what happens when we're given a table of values. All right. So let's look at number 11. We're given H. H is a composition because there's an inside and an outside. I'm going to underline the inside in green, and I'm going to say, hey, my u, my inner function, is 3x squared. If I know that, then I know my derivative is 6x. The derivative of u, I should say. So far, so good. I want to find h prime of negative 1, which means I need to take the derivative of h, which is this composition, and then substitute negative 1. Don't substitute the number early. Substitute it after you take the derivative. So we're going to say h prime is equal to f of u. I'm sorry. H prime is equal to the derivative of f with the inside still in there times the derivative of the inside. So in this case, I can't take the derivative of f because I don't know what f is. So I'm just going to say f prime with u, the inner function, times the derivative of the inner function, which is u prime. Okay, so then that tells us that we're taking the derivative of 3x squared. We're taking the derivative of f of 3x squared times 6x. I have now found the full derivative. So now I'm ready to substitute a negative 1. So then I'm going to say, I'm not going to continue this line. I'm going to create a new line and say h prime at negative 1 is f prime at 3 times negative 1 squared. And then whatever I get there, I'm going to multiply times 6 times negative 1. Well, the 6 times negative 1 is pretty easy to do, right? It's just negative 6. This is asking me to find f prime at 3. Now, I don't have to put this step. If you can do it in your head, then do it in your head, right? Negative 1, plug it into the green function, and you're going to get an answer of 3. Now I'm looking for f prime of 3. Well, f prime of 3, when my input is 3, f prime is 7. So f prime at x equals 3 is 7. So I come back over here, and I say, okay, well, this whole thing is really just 7 times the negative 6 that was already there. That's going to give me negative 42, and that is my answer for h prime of negative 1. Same idea. Notice I didn't have an explicit function for f, so I just said take the derivative of the outside function, so f prime, with the inner function in there, with u in there, times the derivative of the inside times the derivative of u, which is u prime. And then I was able to substitute things back and then evaluate it at negative 1. Okay. Let's try example 12 here. We're looking for k prime of 2. However, k of x is a composition. I have my inside function. So u is g of x. And I know the derivative of u prime, is g prime of x. So if I'm looking to find k prime of x, the derivative function of k, I'm supposed to take the derivative of the outside with the inside still in there times the derivative of the inside. The derivative of the outer function, f prime, with the inside still in there times the derivative. Okay, so therefore, this is the same thing as f prime of g of x. And by the way, the more you do these, and then the derivative of the inside is g prime, you might not need to do this green-orange business every single time. The more chain rule you do, the more you're going to identify the inside function, know what the outside function is, take the derivative of the outside with the inside in it times the derivative of the inside. Like it'll become habit. I'm just using the green and the orange right now to kind of guide you to where your eyes should be going, right? I'm supposed to look for the inside, take the derivative of the inside, now I'll take the derivative of the outside with the inside still in it, and so on. All right, so we're looking for k prime at 2, which is f prime at g of 2 times the derivative of g at 2. All right, so this is what I'm looking for. I need to find g of 2 in the table. I need to find g prime of 2 in the table. So let's find g of 2 first. G of 2 means I'm using the g formula at x equals 2. Well, that's going to be negative 3. So this inside right here becomes negative 3. Oh, but now I need to find f prime of negative 3. Okay, so I come back over here. I'm going to find f prime at negative 3. So f prime at negative 3, that would be 4. So this whole first part becomes 4 times whatever g prime of 2 is. And g prime of 2, g prime of 2, that would be negative 5. G prime of 2 is negative 5. So I come back over here and I say negative 5. So my final answer is negative 20. The instantaneous rate of change of the function k of x, the slope of the tangent line of the function k of x at x equals 2 is negative 20. And that's how we do the chain rule.